in a vector database to perform similarity searches, often used in applications like image search or recommendation systems. A vector representation like 0.9 minus 0.7 minus 1.0 minus 0. 8 is a way to represent complex data, for example, images, text, audio, in a format that can be easily processed by machine learning algorithms. These numbers are called embedding values or features, and they capture key characteristics of the data in a high-dimensional space. Each dimension doesn't represent a specific human understandable property like color or shape directly. Instead, it represents abstract, learned features from the embedding model. An embedding is a numerical representation of a piece of information, for example, text, documents, images, audio, etc. The representation captures the semantic meaning of what is being embedded, making it robust for many industry applications. Essentially, embeddings enable machine learning models to find similar objects. Given a photo or a document, a machine learning model that uses embeddings could find a similar photo or document. The vector embeddings are stored in a vector database. This type of database is specifically designed to store and retrieve high-dimensional vectors efficiently. Vector embeddings are a way to represent complex data, such as text, images, or other unstructured data, in a numerical format that captures the essence or semantic meaning of that data. These embeddings are multidimensional vectors that allow for similarity search and other advanced querying capabilities. Semantic representation. Vector embeddings capture the semantic meaning of data. Vector search similarity, VSS, allows you to perform similarity searches against these embeddings. Vector search leverages machine learning, ML, to capture the meaning and context of unstructured data, including text and images, transforming it into a numeric representation. Searching through data in databases, search engines, and many other applications. For example, finding employees in a database within a fixed salary range. The search terms can be vague and can have a lot of variations. For example, a user can search for something generic like shoes, black shoes, or something more precise like Nike AF1 LV8. If you're searching for images similar to a given image, the vector database will return the images with vectors that are closest to the query vector based on the chosen similarity metric. Example of similarity search. Query vector. 0.9 minus 0.7 minus 1.0 minus 0. 8 represents an image. Stored vectors, either 0, 5, 0.8 minus 0.3, 0, 2, 0, 8, 0.3 minus 0.1, 1, 0, 0, and 0.9 minus 0.6 minus 1.1 minus 0. 7. In this case, stored vector 3 is closest to the query vector because its values are the most similar, based on a similarity metric like cosine similarity. Therefore, the system would return the data point corresponding to stored vector 3 as the most similar match.
Now that we've gone over vector distance metrics, let's explore 3 use cases for vector similarity search: image search, recommendation systems, and fraud detection. Image search. Vector similarity search can efficiently find similar images in a large database. For example, a user can upload a query image, and the search algorithm can find all the images in the database that are similar to the query image based on their visual features, such as color, texture, and shape. In addition to image search, this can be used for object detection and facial recognition. Recommendation systems. Vector similarity search can be used to build recommendation systems that suggest products or services similar to the ones a user has liked or purchased previously. For example, a user's purchase history can be represented as a vector, and the search algorithm can find all the products in the database similar to the user's purchase history based on their features such as category, price, and brand. This ability can be useful in applications such as e-commerce, music and video streaming, and online advertising. Fraud detection. Vector similarity search can detect fraudulent transactions by comparing the similarity between a query transaction and a database of known fraudulent transactions. For example, a query transaction can be represented as a vector, and the search algorithm can find all the transactions in the database that are similar to the query transaction based on their features, such as amount, location, and time of day. This ability can be useful in applications such as credit card fraud detection, insurance fraud detection, and money laundering detection. This is a process flow for using vector embeddings and a vector database to perform similarity searches. Various inputs, likely images, or other forms of data are processed. The inputs are passed through an embedding model. The vector embeddings are stored in a vector database. A query, such as an image or text, is passed through the same embedding model to generate its vector representation. This query embedding is then compared to the stored embeddings in the vector database. The KNN algorithm finds the closest vectors in the database to the query vector based on similarity measures like cosine similarity or Euclidean distance. The results of the search are returned as query results, which likely represent the most similar images or data points to the input query.
Thank you for watching this video.